today's activities. My pleasure at first is to show you essentially the agenda, that'll be a couple of introductions. We'll have a demonstration, we'll have an exposition, and then we'll have a tech talk. I'll give you a little more detail on this. But first, let me welcome our hosts today. Dr. Mike Tischler, who is the Director of USGS National Geospatial Programs, our host today and a sponsor of the Testbed. Please, Michael.
Thank you very much, and thank you all for joining us here on this rainy morning. It's wonderful to have everybody in the same room talking about geospatial interoperability. This is really kind of what brings the power of geospatial data alive, is when you can share the data amongst everyone in a way that's usable and can be leveraged by many people across the globe. My own program, the National Geospatial Program, is a sponsor of OGC, and we have two efforts in the testbed here today that are going to be talked about. One of which focuses around data package, and that's a standard I've been watching in my previous job at the Army Corps of Engineers for a number of years. I think it is vitally important. If you read some of the news about Cyber Monday, you'll read that more people purchased from their mobile devices than their laptops or desktops this Monday for the first time ever. So that shows you just how reliant people are on mobile devices, whether it's tablets or phones. So clearly, figuring out a way to move more data or have data be more accessible in an easier to use manner on your devices is critical. I came out of the military, but there's just as many reasons for it in the civil sector too. We produce a lot of topographic maps all across the country, and there's many of our partners and users that want to have that data on their mobile devices where you don't have cell access. So I'm very happy to see that this is something that OGC is promoting and happy to be a sponsor for that project. The other one is related to the Arctic Spatial Data Infrastructure and the Arctic Spatial Data Pilot. The Arctic has been a huge emphasis for this administration, and hopefully will continue to be in the few years coming. Our role was under the auspices of the Arctic Council, for which the U.S. has been the chair for the last few years. The chairmanship ends in March. When they took over that chairmanship, one of the deliverables was meant to be a more harmonized map, or at least advancing the mapping products of the Arctic countries, those 8 Arctic countries. USGS was the lead agency for that. Through the Arctic Spatial Data Infrastructure Group, we worked on helping expose some of the products and methods and techniques that are available to the international community, and even data, and working on collecting data, helping bring what's been done by NGA and NSF at the Polar Geospatial Center to the international community based on interoperable standards, and making sure that everybody has access to that rich data. So I'm very excited to see that we're going to work today. And just to see that it's progressed as far as it has. So thank you again, and enjoy your day here. We really appreciate all the work that you do.
Thank you, Michael. And now it's my pleasure and privilege to introduce one of who I think is one of the leaders of geospatial information writ large, a gentleman that's been involved in geospatial in the government at the highest levels, in industry at the highest levels, and now in OGC at the highest levels. It's my pleasure to introduce Jeff Harris, who's the chairman of the OGC Board of Directors.
Good morning. It's always great to go to a location-aware conference and see people, in sort of all the available seating opportunities. You can poll people and get data to answer most any question that you want. But when you're driving down the Beltway and the poll comes out that says, what application would people most miss off their smart device? And it's mapping services. And you say, well, how could this be? How could it be like 2016 and people are polling that they would set aside some of the social media stuff in order to engage with the map-like data? It's because of people like you who provide so much interoperability to take place. Now, none of this comes easy, as all of you know firsthand. If you go back to 9/11, following the attack, we formed the 9/11 Commission. One of the senators on the 9/11 Commission was Barbara Mikulski of Maryland. She finished one of the commission meetings, and I happened to be the next meeting with her. And she came in, and at the time I was a federal employee, and she said, if all of the data living in all of the caves came out of the caves to meet each other, would things like 9/11 happen the way that they did? And so she was sort of studying the Bora Bora kind of terrain, and I think laying it over sort of the federal infrastructure of how we collect data. Heather Wilson who was on the House Parliament Committee at the time, sort of said, why is it that so many people that create data think it's their data to hold and not to share? And I said, well, I don't know. I said, I've always understood that the first word that kids learn is mom, and the second word that they learn is mine. And so it's sort of tribal that we gather stuff and we hold on to it. And so one of the things that we celebrate at the Open Geospatial Consortium is standards, but Mark Reichert and I sort of have a contest that when we go in and talk to people, how long can you go without saying the word standards? Because it actually absolutely smothers most conversations. Now, we're sort of in the secret bubble this morning of those of us that celebrate best practices and standards as the enablement of the magic that you see. And today we're celebrating a dozen years of committed people coming together, working real-world problems given to us by our sponsors in order to go make a difference. And the magic that takes place is we actually make it look easy. We make it look easy because of all the hard work that you and your organization represent. So thank you. And so what now happens is, and again, I urge you to try it. You know, every time I get onto an airplane, you sit down next to somebody and you have to sort of, in that 1 second, decide, are you going to look at your book and study it so you don't engage in conversation, or you don't have something to read and you do want to engage in conversation? And I did it this way with the book one day, and it turned out I was sitting next to Art Garfunkel of Art Garfunkel fame, and the conversation ended up, because here's a fact that you didn't know, George is big into music. He asked what I was at the time, and I said spy, and I said, what are you? He said singer. And I said, who's your favorite group? And usually you want to know the answer to the question. Like if you had to go to your next cocktail party, Art Garfunkel's favorite singer was Huey Lewis and the News. And so this is a brought for you from Mark Reichert, the music theme of the morning. But what you find is that if you say to people, I cause dots on maps to come alive with information, you can never go back to your book, because they want to know how all this magic, like how does it know? It's like the thermos bottle. How does it know whether to keep it hot or keep it cold? How does the map put all the POIs in exactly the right place? And as Mike says, we now connect and disconnect from the network. The kinds of capabilities that we've enabled are all on the backs of the giants that had the vision to take the technology that's coming at us at unbelievable speed and taking that technology and harnessing and making it double-click easy. So I'll close. Back to the 2-year-old who's learning the difference between mom and mine. True story, as he walked up to the large screen, moved his finger across the screen and the data didn't move, and then burst into tears. This is a person who is clamoring in 20 years to be part of OGC Testbed 24. So thank you, and look forward to this study.
Thank you, Jeff. Appreciate your comments. We are in the bubble, right? So what are we going to do to get out of the bubble is the topic of the next couple of hours. And what we have for you is essentially 4 things. One is I start off with a little bit of an overview about OGC. Some of you will find that repetitive because you've seen it 12 other times or more. But some of you will be enlightened perhaps with things about the direction that we're headed that you maybe didn't know. Second, we will have a demonstration, a description of the technology that's been developed by Luis Bermudez in a scenario-based approach, which tells people what difference does it make that we have developed this new technology. This is one step to getting out of the bubble, right? Don't tell me about the square brackets versus the angle brackets. Tell me about what difference it makes in terms of making judgments and decisions when I see social media and I see protests in the street. How can I put all those pieces together? And that scenario is what Luis will tell you about before the break. During the break, we'll ask you, we'll give you the opportunity to go out and mingle with the folks that built the technology that you saw in the exposition that'll be out here in the hallway. It's a chance for you to work directly one-on-one with the participants in the test bed and ask them questions about their technology. You may not get all the answers you want in the sense of it's complex technology. You may not get a full picture of what all the technologies involved. So to answer that then, come back in here and we'll have a tech talk led by Ingo Simones, the lead architect for the test bed, to kind of pull some of that back together and give you a sense of what is the technology that underlies that. So when you leave the bubble, you'll be able to say, I know how the dot gets on your screen, and I know how the dot moves around behind that screen. That would be our objective today. So that's your agenda. Let me first start then with a bit of an overview about OGC and how we are turning data into usable information through what we call the Interoperability Program. The OGC mission overall is to serve as a forum and, oh, by the way, develop standards. And so, as Jeff said, this competition about, yeah, we're a standards organization because that's what lasts, that's what's going to outlive us, that's what's going to be here in Testbed 24 is not us, but the written and otherwise documented items that go forward in our technology. Those are the standards. But how do we get there? How do we get there is a social process of gathering folks together, the best software developers of geospatial in the world assembled for Testbed 12, producing what is going to become standards in our standards program. So that's the mission of OGC, is that the full delivery of full exploitation of location information in a variety of missions. You may know some of this history about OGC, founded in '94, 40 plus standards, 500 plus organization members, 5,000 users in the portal, 230 OGC certified products, an additional 800 that claim implementation. We hope those move towards certification. One of the regular questions I get asked is, I'm using products that claim they're OGC, but they don't work together. And I'd say, well, have they been certified? Well, no, they told me they work together. I said, well, that's nice, but you ought to get those products certified. So if you haven't talked to Luis in our compliance program about certification, and in particular if you're a program manager and want to get procurements that match OGC standards, make sure you have certified products. The last line then is we've done interoperability projects like this about 90 times, more than 90 times. We've done 12 test beds. We did 2 web map test beds before that. We've done a bunch of pilots. We've done a bunch of studies. And so we have an established process for this innovation, agile development and the like that is itself undergoing agile innovation and the like in terms of its process. So it's a learning process every time we do one of these test beds. You would know that OGC has 4 programs. The Interoperability Program is where you sit today. The Standards Program is the Consensus Program. So where running code wins in the Interoperability Program, it's people voting and consensus that gets us to standards in the Standards Program. I've mentioned the Compliance Program, which is the tests that allow us to certify software, it allows the vendors to certify their software is compliant, and allows procurement officers to request compliant software in their procurements. And then communication outreach to get us beyond the bubble. And we need that help. Denise and their crew help us every day to turn what we have as tech speak into things outside the bubble. So let me focus on the Interoperability Program. It really is an innovation lab. It is an area, an activity, a process where we're focused on developing new ideas, refining the existing standards, improving them and the like. We've got this metaphor of an innovation lab. We really don't like the chemistry set metaphor graphic there, but we haven't found a better one. We definitely like the innovation phrase. And so, in fact, what we are in the middle of is a transition of the name of the Interoperability Program to the Innovation Program. So over the next few months, you will see this name change from the Interoperability Program to the Innovation Program. So, of course, the real key thing there is we save the acronym, right? It's still IVA, right? It's a top part. So we do innovation. We develop things that end up in the standards program. And we get a lot of participation. We get a lot of activity from a lot of organizations, both from government, from commercial industry, and from academia. And the question is, why does that persist? Why do people come and participate in the like? It's really kind of an economic question. Why do folks invest? It's in part, of course, because they get outputs that they can put into their programs. It's also because it's an effective economic way to collaborate in a consortium process. And the indication of that from an economic point of view is that for every dollar that gets invested by a sponsor, there's roughly $2 of activity that get performed in the testbed. And that's due to the folks leading the participants, due to the participants. They contribute that other dollar of effort. Why do they do that? Not because this is a charitable organization, but because it benefits them. They come with their research and development hats on, they come with their risk reduction hats on, and they participate in the activity because it helps them, and then collectively it helps the groups that come together in terms of the Interoperability Program or the Innovation Program. Let me specifically then thank the sponsors for this testbed. These are the 7 organizations that sponsored, provided the seed money and the requirements and the direction and the refinement, the leadership with respect to where this testbed has gone. Thank you very much to these organizations. We then have a set of participants. These are the organizations that did the work, did the labor, did the brain thinking, did the software development, did the scenario development and the like. These are your leading geospatial software developers in the world coming together to advance the activities and the like. One further group, and that is the staff, if you will. And so in the middle is Terry Idle, who's hiding somewhere. Where's Terry? Terry is over there. Terry put this show together. He is the head of the OGC Interoperability Program. He plays quiet during these things, so I always thought that was interesting. And I'm pointing him out. Terry. So thank you, Terry, for pulling this together. The 2 leading folks for the overall testbed, I mentioned Ingo Sabunes is the initiative architect. Ingo, raise your hand. There we go. Scott Sarich is in the room, and he is the essentially program manager for the testbed. Luis, you'll see in a minute. If you don't know Greg, I'd be really surprised, but Greg is right there. Charles is not here. No, Charles is not here. Led the aviation thread, and Lou is also here. Lou, there he is. Lou's been around since about when I started with this on staff in 2004. So welcome, Lou. Unfortunately, Lou's beginning to fade. He's trying to retire, but we won't let him. So, testbed 12. In terms of statistics, the largest one ever. In terms of dollar amount sponsorship, in terms of the number of components, which is software, schemas, anything like that. Number of documents, 47 engineering reports, user guides, data descriptions, various things like that. Over 37 organizations. I keep asking Scott Sarich to pin that down. He says, well, another one joins every day. So I'm just going to say this. So he says greater than 37, greater than 200 individuals participating in testbed 12. It was organized in this area. We call them threads. You can think of them as working groups. They're also thematically involved, so they have some technological clustering, some cohesion within the clusters, within these threads. That allow us to work independently as working groups, but then bring it together with coupling, loose coupling, into an overall testbed. You see those listed there as the 7 threads and the 130 deliverables by the various threads. Let me give you some examples. Obviously, this is a large set of documents. We're going to give you exposure to this development through both the scenario, the exposition, and the tech talk. Let me give you one example of a thread, of a path, not to confuse the word thread here, of a path of the development in testbed 12 into the greater reaches of outside the bubble. So how do we get outside of the bubble? Kill that metaphor, Jeff. I like that. Yeah. So testbed results into the standards program. The results go broader than the standards program. Ingo will actually hit on that a little bit in the tech talk, how we reach out to the community directly from the interoperability program. This focuses on the standards program. We took a very strong effort during Testbed 12 to have a much richer interaction with the standards program working groups early on and often throughout the entire process. So there was early interaction. Each of the working groups was notified that we thought this engineering report related to their standards program working group. We got confirmation back of that. They edited the scope and the like. They committed to review it, and if needed, in several cases, actively participated in the review of the engineering report as it's being developed in the testbed. And out of this delivery of the testbed, then the working groups will review those and start the process to make them publicly published documents. And that's all really good. But what happens? What happens after we deliver it to the standards program? How do we actually get that institutionalized and the like? So let me give you an example of one area in which we have a heavy emphasis in Testbed 12, and that is the evolution of OGC Web Services. You may know that we have a set of documents that go by the name OGC Web Services since about 1999 with the first web map service. But now we have web feature service, web coverage service, web map tiling service, web processing service, and a variety of other services, the suite services that build on that. We know we need to continually evolve those while keeping the existing baseline in place because those are operational in many areas. How do we do that? And what are the results of Testbed 12 that help with that? The Testbed reports will come out. There's two of them that I'll highlight regarding evolution of web services. They both have the term REST in them, very resource oriented. One is a user guide, how someone would build a RESTful service based on OGC guidance, and then an architecture ER, which identifies the resources that are geospatially motivated. So within REST, one of the key steps that's always identified is as a very key essential first step is to identify the resource types, the names of your resources. If you look at that document, 16035, the OGC number for that document, you will find such a comprehensive list of resources identified in that architecture document. That's going to come into the standards program where we have an API white paper that's been developed over the last year. Next week at the OGC standards meeting, we anticipate a motion to approve that. As a public white paper, it indicates the first thing you ought to do is resource identification. The other thing it talks about is API management, which includes things like the Open API Spec, formerly known as Swagger, and how you use those tools and the like. And then the other activity I'll point out that's going on in the standards program is the W3C Spatial Data on the Web Working Group. So all of these things come together, a big kick in the butt from Testbed 12 because of the implementation that has been accomplished behind those two documents, but then melded with the activities in the standards program will kick the SWIGs, the standards working groups, in the butt in order to revise and evolve their OGC web services based on, for example, RESTful practices. So that's what we got to do leaving here. You'll see a whole lot of activities that relate to this RESTful activities in the scenarios, the exposition, and the tech talk. Okay, let me finish up. So we have requirements from the sponsors. We've done a lot of work with respect to developing technology. We want to put it together into a story that tells what difference all that technology makes. We call that a scenario. We want to give you that story now, give you some real-world scenarios and how the technology that's been developed is shown in a demonstration. So for that, I'll invite up my colleague, Luis Bermudez, and he'll give us a walk through the scenario for Testbed 12.
Hello, everybody. Thank you, George. So, as George was saying, the demonstration. So, what I'm going to do is to try to tell a story that you can see how all the technology that all the participants advance can be put in place in real scenarios, in emergency response. So hopefully you will like the story. It has some components. Let's see what we're doing. You cannot record directly from PowerPoint? Good. So there are four main components of this scenario. First is the idea of we have problems with climate change, and we're going to build an Arctic spatial data infrastructure. How do we do it? What are the technologies to enable scientists to share data? That's one. Second, we have some data scientist geeks, and they're doing an anti-fracking protest because of the methane that goes into the air, and they're in San Francisco. So we have the San Francisco local authorities to try to monitor the project. Third, at the same time that we have these protests, an earthquake occurs and fires are caused also around San Francisco. So how do we support the emergency response in this case? And fourth, well, we always have this aviation component, that is, what happens if an aircraft is going to land in San Francisco? Do they get notified? Do they get rerouted? How do we deal with that situation? All using open technologies. I didn't say standards. Okay. So as you know, global warming is happening. And the Arctic provides early indicators about global warming. To understand the process and advanced solutions occurring in the Arctic, it is essential to integrate this data from different sources. So usually organizations are silos and they publish the data somewhere, however they want. But researchers, analysts from agencies, private sector, everybody that needs data, they want a more holistic picture. They want to go to a centralized place to be able to get the data, search by topic, search by region. And in the demo, we're thinking, well, so we call this the Arctic Spatial Data Infrastructure, which is a good system that allows a person, a user, to search for different resources, to different sources, for example, services or data, to better understand climate change. So at the heart of these spatial data infrastructures are catalogs, and these catalogs are very cool applications that enable users to search and discover relevant resources. However, sometimes there are more than one catalog, so what do? In order to avoid the user to go to every catalog and search, what we do is to do a federation of catalogs. So we enable a solution where the user can go to one catalog only and then search different catalogs. Here you can see the diagram. So this catalog or mediator catalog was based on data catalog vocabulary DCAT use Sparkle server that enables this client to just contact one catalog and provides this nice information to the user. The DCAT is a server connected to a federation of catalogs, and those were semantically integrated. The difference is that we advance the DCAT to enable more geospatial metadata and searching. So a client interacting with DCAT server can show the results in a very convenient way to the user, enabling the user to find and evaluate relevant resources. So this is DCAT geospatially enabled, and DCAT is a W3C technology. Now, by using federated catalogs, analysts and scientists can get some data like digital elevation models, like average temperatures, forecast models, or any data related to the permafrost. And users can also view other related data, zooming into a region of interest, and this is the coolest part, is calculate data on the fly. For example, such as in this case, is calculating the average temperature in a watershed. And all using these open interfaces on the back end. So the work that we've been seeing is going to be further advanced in the current Arctic Spatial Data Pilot that was mentioned at the beginning. But this was some of the work that we did at the testbed. So that's the first part of the story. So we have seen the Arctic. We have created spatial data infrastructure to support users to search, find information using catalogs, federated search, and advancing technologies like DCAT. Now let's talk about fracking. So another process, one of the processes that can induce climate change is fracking, which releases methane to the atmosphere. But similar to the Arctic, let's say the data from fracking comes from different places, and we want to integrate this into the spatial data infrastructure. And so that's one part. But then we have these guys, which I call conscious, outspoken, green data scientists, that started an anti-fracking protest. You know, following similar social responses to other type of events, they're just fighting for the planet in their way. The protest was followed very closely by government officials. They were able to map the road digitally to see where the protesters were going, and the data on the back end followed a general feature model that allowed to associate all types of data and support decision making. This is social media feeds, routes, multimedia data, alerts, and in particular I want to highlight the rich associations that can be done from one type of data to the other. So you see, for example, alerts can be or associated with messages, with some calculations, safe distance, and with position that comes from vector data, for example. Another analyst, let's see, now we have another analyst that is part of the group following the protest. It's a data scientist, and it's advancing methodologies to use semantic web tools to leverage and find even more associations using the semantic web. So data was available via OGC services, and as was George mentioned, we prototype and we advance a REST architecture, and we also made data available not only in GML but also in JSON and RDF that will allow to create more association and to use even more clients that are able to speak the new web architecture paradigms. The data scientist is searching for threats. This is related to the protest crowd. And the analyst opens a client that is connected to a web object service. The web object service allows to access any kind of data and the associations related to that data. Video streams, audio, databases, raster data, Twitter feeds, you name it. The associations, in this case called communications, lead the data scientists to discover a communication type object. This one. It's a suspicious artifact. Doesn't look like, but it is. Careful. That the protesters might use. Right? It may require even further investigation to see what this suspicious artifact is about. But don't get scared. Now, similar to the Arctic is the ice scenario, we were building a central catalog for climate change data. We can build an SDI at a city level to deal with threats, not even from protesters, but earthquakes, fires, and so on. So each source organization or agency needs to publish their data to a central catalog. For example, San Francisco Spatial Data Infrastructure. The Web Integration Service allows a service providers to easily publish a list of services from one public's capability documents. So if you remember in the past, every type of service has a capabilities document that needs to be registered. Now there is only one called Web Integration Service, a capabilities document, where you can go to an interface, user interface catalog-like, and register that document, making it easier for the folks that are providing the data. The advanced catalog capabilities enable the linking of catalog records with services, layers, features, and others. Right? So at the moment of cataloging, we can create these rich associations, but also we can also provide constraints related to security and access of data. So at the same time that we have the protest, a rupture occurred in the San Francisco Andreas Fault, causing a 6.8 magnitude earthquake in San Francisco. Significant damages to the infrastructure have occurred in the city, affecting roadways, bridges, making many of them impassable. Power has been lost in many areas due to damage to power lines. Cellular communications are down. So now this is the third part, an earthquake. So an emergency command center was established to aid in the evacuations, response, and recovery. And sharing of critical data when this happens is critical, right? Roads, building data, power distribution networks. And including properly dealing with classified information and who can access what. So the San Francisco Spatial Data Infrastructure plays a critical role to be the central place that efficiently allows the discovery and access of data. The analyst from the command center searches the catalog, right, in this SDI, displays the data and selects the critical ones that he would like to share with other folks at the command center. And they use the OWS context. So we advance this technology that allows to share a common operational picture in a very easy way. The other user at the command center opens this OWS context document and can replicate the information that the other user was looking at. So based on the OWS context document, an analyst can interact with data coming from OGC services. So the analyst, via the client, discovers data from California, loads resources into the client, for example, searches for water bodies, and can immediately see data coming from a web feature service, the FST server, searches for elevation data, and can see data from a web coverage service, can search for land cover data, and can see national land cover data coming from a web tiling West server. And the approach to use tiles, we have mentioned tiles a little bit, to allow efficient requests to millions of images on the web have been very successful. So a similar idea was prototyped to interact with millions of features. So 30 gigabytes of OpenStreetMap data was made available, extending existing feature-based tile solutions that allowed an analyst to easily navigate through the data in the San Francisco area. So the analyst gradually zooms in, showing increased amount of details, and because of the tiling and the multiple levels of the tiles, the client can smoothly access all these data without any performance issues. The analyst can also access a service that streams LiDAR data via sensor observation service, allowing very fast visualizations and interactions like never before. The command center will also like to subscribe to get aftershock events. So a client application using OGC PubSub interface creates a subscription to seismic events from an event web service. The data is coming in the back end from the IRIS Data Management Center following a web service protocol specified by International Federation of Digital Seismographer Networks. The user pans, selects a region of interest for the subscription, subscribes to the event, and the application then notifies the user that certain numbers of events have been received. For example, in this case, shows like 10 events are available, and the analyst can view the locations of the events in the map and can read more detail about any specific event. Now, not everybody at the Emergency Command Center has the same credentials. Some information is classified, and in order to be retrieved, the user must supply the correct security certificates or credentials. So the Command Center, as well as other agencies, are required to support different access request methods, including HTTP, GET, POST, SOAP. SOAP in some cases increases the security in asynchronous processes, but in this case, the analyst with approved credentials was able to get data via SOAP services, you will see here on the right, to see classified construction sites and to spot a place to land a helicopter that will support search and rescue, while the person without credentials cannot see that information. So it's possible to hide some data using OGC services. Now, what we also can do is, if a user has no credentials when trying to access information, we can return a tile with an X, marking very explicit that data is not available. So you either not show, or you say, sorry, you cannot see it. In the first case, they will never know. With the non-licensed cellular networks down, data cannot be shared using cellular connections. So we need to find another way to share data. Humvees that have a mobile server inside pull into the command center compound and synchronizes with the command center server. For example, getting all the temporary shelters received available for a region. Now, if the rescue and operations crew spots another possible shelter, and they have this application in their vehicle, they can update the data, adding another shelter. The speed of transmission of the data greatly improved since the last operation, let's say a year ago, due to the updated services that allowed to compress the data via Web Feature Service. So the data was sent using compression methods like ICSI and GZIP. So when the Humvee gets to the command center, they can zip the data and synchronize using these zip data files. Now that the shelter, the next time the Humvee gets to the command center compound, it will synchronize the data, sending the new shelter location to the command center, and maybe retrieving new temporary places that other Humvees have gathered. Response centers can also exchange or synchronize information in a similar fashion. It's not only mobile devices and Humvees with the command center, but response centers can synchronize via OGC Web Feature Services that have been set up, like in this case we did, in 2 cloud environments. In some cases, having all the corpus of data replicated in 2 places is beneficial. And synchronization maximizes the request and response that servers and clients are required to perform. So roads got affected, and we have another option when there is no communication. Some of you are familiar with UPackage. UPackage is an OGC standard platform-independent container for all kinds of geospatial data. And the command center generates this UPackage that contains multiple data sources, as well as tiled satellite images, elevation data, for example. And responders with a mobile device can interact with your package, view it, and make analysis even on the road. So, as an example, a first responder has a tablet with a GeoPackage-enabled application. So he has a GeoPackage file. This GeoPackage file has raster elevation data and has some vector data such as the road closures that you saw in the video that the roads were affected, wildfire boundaries, and hydrography. But the first responder wants to calculate the best route between 2 points. And this calculation wants to avoid any obstacles, like roads that were closed or water bodies. And he's doing that in real time in the mobile device because your package enables to do that kind of operation. The analyst in the command center also wants to style the data with NGA-like symbology. And he uses a client to get vector tiles in your package and invokes a symbolization algorithm via web processing service to style the data. Now, this web processing service to style data can be reused by a lot of folks in the command center. As we have seen, the command center is accessing data from different organizations. And in the process, they require to clean the data, which entails inspecting the quality of the data, inspecting the accuracy, and doing some merging and conflation. So to qualify any new data to be used in operations, a quality check is performed on the new data set. The new data is compared to an authoritative data by selecting a random sample of points and a percentage threshold. In this case, 20 points were selected and the percentage of failure was set to be less than 20%. The data quality process returns the sample points, including the result of the matching and the quality elements that help the user to get more information about the quality checking process. Inspecting accuracy of images is also important for the command center. So an analyst gets a mosaic of stitched satellite images that come from different data providers via an OGC Web Service. The service provides for each piece of the mosaic accuracy metadata that enables the analyst to visualize a subset of the coverage and to compare and decide if the data is accurate enough for its own purpose. Finally, the analyst is interested in merging complementary data to the authoritative data. So it seems that in this case, OpenStreetMap data provide extra information. So the analyst performs a conflation process using the tool HUD-NANI, which is executed as a REST OGC web processing service. And the data that has been merged is highlighted in green, and the new additions, you can see them in yellow. I also want to emphasize here that making available the conflation tool as a web service allows the reusability of the tool by all the users that are interested in doing this kind of operation. So now we have fires. So that's why I need water. The analyst at the command center runs a model that computes dispersion of smoke. So the client accesses a Spatial web coverage service to view the model results. The service implements the Earth observation profile that enables the analyst to view the data in 3D space and 1D time. The web coverage service can also access data coming from OpenDAP, from DAP4 and NetCDF formats. Interoperation between disparate and aligned data is a big problem that OGC solves with web coverage service to access the data and the discrete global grid system standards. In this case, the dispersion of potential hazard particles in parts per million is modeled and delivered to this spatial grid, the discrete global grid system, as a time series web coverage service from web coverage service following the Earth observation profile. So this grid allows to easily merge data from different sources. A wildfire has been reported along an expected evacuation route, so an analyst can get the fire extended boundary via a web service, and then encode this boundary in GeoPackage that will allow the first responders to carry that data in their mobile devices. However, the analyst wants to transmit the data in a more efficient way by reducing the size of the file. So he ran an algorithm called generalization computation via cover services and is able to reduce the size of the file by 85%. So we've seen how sharing of data has been improved because we have provided better ways to synchronize the data, right, to make the data smaller, and also to be able to receive messages and to subscribe to subscriptions. Now the last part of the demo is the aviation part. So now there's another agency involved in this scenario, and is the Federal Aviation Administration is worried about the smoke events and want to issue a temporary flight restriction message to notify all the aircraft operators about this restricted flight area where normal planes cannot fly. The affected area can only be used by firefighting aircraft operations. But before sending the message, the operator performs a check on that message. It is encoded in something called Semantics of business vocabulary rules. And it checks that the area matches the area of the incident of the data, and that the data is properly formatted and complete. The rules are converted to something called schematron that checks the XML validation. And once the message is fixed, it can be submitted to the others, to other operators via OGC Web Services. So meanwhile, an operator of the Green Airlines is scheduling a flight from Atlanta to San Francisco. The flight information is exchanged via a web feature service that uses an encoding called Fixer, which uses GML to encode geometries. The pilot is preparing to push back from the departure gate and wants to get more information about the flight. Is it going to rain? He performs a simple search by specifying an aircraft identifier in an OGC client application in the cockpit. The application is connected to a data broker that discovers all the necessary services from a registry and provides the functionality to allow the pilot to do this pre-flight searching briefing that includes the flight plan, weather, and all the detailed information about the airspaces. The client and the data broker understands the web feature service and various encoding formats. So details of the San Francisco airport are encoded in the aerodrome mapping exchange model format, and for the Atlanta are encoded in the aeronautical information exchange model. However, this is transparent to the user. And the reason it's transparent to the user is because in the testbed, we develop a transformation capability to convert the aerodrome mapping data to aeronautical information data. The conversion process also captures all the provenance and lineage information required for quality assurance process. So the flight is on its way, and the airline operator checks for updates. In particular, he's interested in flight restrictions along the flight plan. He uses in the backend an OGC Deliverables with temporality extension that allows the operator to make a temporal and geospatial query. The flight is intersecting the temporary flight restriction issued by the FAA, and the operator can amend the flight to avoid that restricted area. An operations center in LA supports Los Angeles International Airport and subscribed to Los Angeles airspace, but was asked to support the San Francisco airport. So the operator subscribes to a filtered event-based information occurring in the San Francisco airspace. He uses this client, again we're using the OGC PubSub standard. And now the Air Operations Center in Los Angeles receives notification related to the San Francisco airspace. Now, a couple of weeks have passed, the Air Operations Center returned to its normal operation, so now it's only monitoring the LA airport. The smoke plume has disappeared. Everything is returning to, let's say, normal conditions. The command and air operation centers, they were to successfully support the emergency operations because they were using open interfaces, standards, proven web architectures, and more importantly, they were able to reuse software and be able to integrate data in a more efficient way. So that's the end of the demo, where we tell the nice story. I hope you enjoyed it. Now I'm going to talk a little bit about the participants and the deliverables. So I'm going to mention the participants by thread, and then I'm going to show the reports so you can make annotations if you want to further inspect some of the reports. So the aviation thread at these participants, and these were the documents. So there is one that deals about the catalog, one that deals about the brokering, synchronous messages, the SBVR, which is the semantic business vocabulary rules, the architecture, security, semantics, and the fixed GML. These were the command center thread participants, and remember that some of these participants are going to be in the exhibition, so you will be very glad to discuss how they did the work. And these were the documents, engineering reports that came from that thread: WFS synchronization, SOAP user guide, OWS context, OWS common security extension, LiDAR streaming, OWS context capabilities, the web integration service, OWS context using JSON, JSON link data, HTML5. This is the compliance thread and consolidation participants. So in the compliance thread, we have advanced packaging the testing tool that we use called Team Engine in a virtual machine. So if you want to do that, you put it in a secure environment, now you can do it. Also, we have a user guide for profile testing that talks about how to develop profiles and make them available in the OGC testing infrastructure. Also, another report about WFS2 test. So now we have a complete test for WFS 2.0, and also details about the reference implementation. And for the consolidation thread documents, we have a Testbed 12 web service implementation engineering report, test data set implementation with documentation, and test data symbols and styles implementation with documentation. The field operation had the following thread participants. And these were the engineering reports. So there is one that discusses vector tiling, how to implement vector tiling, how we did the compression. And remember, all these reports tell what we did, the gap, what's next, and sometimes provide very good tips if you are, or guidelines, if you are implementing any of these type of technologies. And it is your package profile, which is a very specific implementation for MGA, your package routing and symbology, your package mobile apps integration, your package change request evaluation, your package US topo, and low bandwidth and generalization. The large scale analytics had the following participants. And these were the reports. So implementing synchronous service response engineer report, pops up, catalog, big data database, multi-tile retrieval, WPS conflation service, WPS ISO data quality service profile, imagery quality and accuracy, WCS profile, and WMS, WMTS enhanced. The LDS had these participants, and these were the documents: REST architecture, JavaScript, JSON, JSON-LD, Topo JSON, GML, evaluation of semantic enablement, REST user guide, GeoJSON user guide, semantic portrayal registry, semantic mediation catalog, Spatial, general feature model, UGAs and shape change, and Arctic SDI. Want to talk about this bit?
Sure. So thank you, Luis. Let's give Luis a round of applause. So let me say a couple more things before we step out to the exhibit, and maybe a time for one or two questions. But in particular, so first, Testbed 13. So the reward for good work is, of course, more hard work. And some people have heard me say that before. So Testbed 13 is underway. It's in planning right now. You see the topic areas that are being discussed. Another good graphic presentation by Ingo, pulling this together to show those clusterings of functional areas and the like. And so if this is of interest to you, or you like the process and you're interested, talk to myself, Ingo, Terry, any of us, you get involved in Testbed 13. More of the good same thing. Thank you to the sponsors for Testbed 12. You've seen those names before. Thank you for the participants in Testbed 12 that we've just seen. So what is next is a set of exhibits out in the hallway this way to my right.
We have a sponsor stand up in this.
Oh, sure. It's not a bad idea. So we want to honor the sponsors and let you know who they are so you can talk to them as well. So if you would, if you're a sponsor representative, please stand up and also thank you. Like I say, exhibits in the hallway. You see the dozen or so folks that will be out there: EOX, OpenDAT, Esri, Envisha, Jacobs University, Pixis, GMU, University of the Bundeswehr, CompuSalt, and Digital Globe. So thank you all for coming and participating, ask them questions. The plan is to be back here at 11:30. Let's make that 11:35. Because we're at 5 after right now, but I do want to allow for any like super burning questions, because I want to answer a question that most people ask, and that is kind of related to this slide that Luis put up. And typically the question that I get is, well, lots of good new stuff, lots of new standards and the like. Some of those things I've seen before. I've seen delivery of plumes, I've seen delivery of features, I've seen processing of data on the web. What you have not seen in particular in many of these applications is that accomplished by independent implementations. That's a very nuanced thing that is hard to present here in a presentation. But everything that you've seen is based upon distributed services, independent implementations, operating over an agreement that will become a standard. That is one of the key things you want to keep in mind as you think about how do we move into a world of open standards and open sharing of information. That underlies what you've seen there. There's a burning question. We could take it now to benefit all. Otherwise, please join us for the exposition. Come back at 11:30 for the tech talk. And thank you to all for attending. Thank you very much.